the antiderivative and sample problems. I will show to you how to solve some sample problems using only the definition of the antiderivative, using the list of basic forms of the integral, and of course using your fundamental identities in trigonometry. Let us obtain the integral of x cubed minus 3x plus 2 divided by x dx. So at the first glance, you might be tempted to get the you might think that this is how you do it. No. We have no rule that says this is what we can do. So what you can do here is you can separate this rational function into separate terms. 3 separate terms, okay? Look at that. So why did it become the integral of x squared minus 3x? No, x squared minus 3 plus 2 over x dx? Well, we just okay, and so this is equal to x squared minus 3 plus 2 over x. So here we can apply the linear property of the integral. So for the first term, we can apply your power rule. Okay, you will add 1 to the exponent and then all over the sum of the exponents. The integral of 3 dx is just 3 times x. And then plus the integral of 2 over x, okay? You can write this as 2 over x dx, which is equal to 2 times the integral of 1 over x dx. And you know this to be equal to ln of x. Now you might be thinking, why do you have to put x inside the absolute value symbol? Well, that is because when you are evaluating the ln function, okay, the expression here, the value of that cannot be negative. Okay, so it is something to do with the domain of ln of x. The domain of ln of x, okay, would have to be x such that x is greater than 0. Okay, so you have to take the positive, the absolute value of x. So we are done with letter A. This is the antiderivative. Letter B. Let us obtain the integral of 5 times the square root of x minus cube root of x all over x dx. So we will apply here what we did to the first problem. We will separate this into 2 terms. Okay? Now, why did this become x to the negative 1/2? Well, you applied the laws of exponents. What is square root of x all over x? So that's just the same as x raised to positive 1/2, okay, minus 1. And this is equal to x raised to negative 1/2, okay? And it's the same with this term, okay? We only applied the laws of exponents. We separated the original function into 2 terms and we applied the laws of exponents. Here, we shall now apply your power rule for the integral. So you will add 1 to negative 1/2. What is the sum? The sum of that is 1/2 and then all over 1/2. Look at that, look at that. And then minus x raised to 2/3, okay, and then 2/3 you will add 1. And what is that equal to? That is equal to 1/3. And then this term all over 1/3, okay? That is how you write it. And then plus c. And then this one is the same as 5 times the square root of x times 2, okay? So this one is the same as 5 times 2, which is equal to 10. And this one, okay, you have a 1 there, 1. So 1 over 3 is just 3. So this is our antiderivative. Obtain the integral of 1 over the square of cosine of x plus 5 times the square of sine of x plus 5 times the square of cosine of x dx. I hope that you can see now that when we are obtaining the antiderivative of functions, it's very rare that the functions that we shall be working on are functions that belong to the list that I gave you. You know, the basic elementary forms and the basic forms for trigonometric functions. And so what we will do here is we will look for those identities. Maybe they can help us. Well, I hope that you can recognize this to be the square of 1 over cosine of x, which is the square of secant of x. This one is just this, the integral of the square of secant of x. And then 5 is a common factor. We factor out 5. Okay? So it becomes 5 times the quantity, the square of sine plus the square of cosine. Now, this one is already listed in your table. Okay, so we can now tell that the integral of the square of secant of x is going to be tangent of x. Now, look at this one. This is just your Pythagorean identity that is equal to 1. So this one becomes the integral of the square of secant of x dx is equal to tangent of x. This one is just 5 times 1 dx. And the integral of that is just 5 times x. And then, of course, plus c. What is the integral of 1 minus cosine of x over the square of sine of x dx? Again, it does not belong to this list. But maybe we can do something about it. Maybe we can find an identity that belongs to this list. Okay, so let us work on this function. Well, again, you can separate this into 2 terms. 1 over the square of sine of x minus cosine of x over the square of sine of x. And you know this to be the square of cosecant of x. It is already there in your table. It is equal to negative cotangent of x. But what about this? What about this? Okay, let us see. Now, how did this function become cosecant of x times cotangent of x? Well, cosine of x, okay, and the square of sine of x, you can write this as 1 over sine times cosine of x divided by sine of x. Okay? And so this is cosecant of x times, and this now is cotangent of x. Okay? So there you have it. So our function now are among the basic forms, okay? The integral of the square of cosecant of x is negative cotangent of x, and then minus the integral of cosecant of x times cotangent of x is equal to negative cosecant of x. So minus negative, it becomes plus. And then, of course, plus c. Let us get the integral of the square of tangent of 3x plus 6 times cosine of 3x dx. Do we have square of tangent of x in our list? No, we don't have it. But there is an identity that can help us with the square of tangent of x. Okay, and what is that? Okay, this one. Okay, this one. Look at this. So from your basic fundamental identities, you have this identity 1 plus the square of tangent of x is equal to the square of secant of x. So this means the square of tangent of x is equal to the square of secant of x minus 1. So this one will replace the square of tangent of x. Now, what is the integral of the square of secant of 3x dx? It's there in your list. It's 1/3 tangent of 3 times x. What is the integral of 1 dx? It's just x. Okay, so what is the integral of 6? Okay, 6 times cosine of 3x dx. So you just copy 6. And then the integral of cosine of 3x is 1/3, okay, times, okay, so this is wrong, okay. This should be sine. This should be sine of 3x. I'm sorry. And so what we have here is this one, okay. 6 divided by 3 is 2. And then let us correct this. This should be sine of 3x plus c. What is the integral of sine of theta, cosine theta, d theta? What fundamental identity? Well, actually, it's not a fundamental identity, okay? When you say fundamental, it's the first identities that are introduced to students when they study trigonometry. But this one is not a fundamental identity. Well, maybe you can still remember your sum of angles identity for sine. This one is sine of 2 theta, but I wrote it as sine of theta plus theta. That is the same as sine of 2 times theta. Okay, I hope that you can still recall this. When I was a student, I memorized this as sin cos cosine plus cosine of theta times sine of theta. These one are the same. So this is equal to 2 times sine of theta times cosine of theta. Okay, so we can now obtain another function that can replace sine of theta, cosine of theta. And that would be sine of theta times cosine of theta is equal to 1/2 sine of, okay, so this is 2 theta, sine of 2 theta. So this is the function that we shall use to replace sine theta, cosine theta. So what is the integral of 1/2 times sine of 2 theta d theta? Okay, so we will just copy 1/2. And the integral of sine of 2 theta is 1/2 times negative cosine of 2 theta. Okay? So 1/2 times negative, so 1/2 times negative 1/2 is equal to negative 1/4. And cosine of 2 theta plus c.